All right, let's look at part B. So what do we have here? 1 over 4 times the cubic root of n minus 1. So let's call this to be an. So we have series an. Okay. Like in the previous case, when n gets larger and larger, the bottom is governed by the n-related term, but not 1. So this term is minor. So then this series looks like this one. Okay? And in fact, I can write that in the exponent form. 1 over 4 n to the 1/3. Okay? So now the question is like, calling this to be Bn, what is the relationship between an and Bn? Well, here's the relationship. So you have minus 1 here, right? You have minus 1 here, and then this term here, this quotient here is a quotient where the bottom is always 1 less of the bottom of this. Okay, so you're dividing by a smaller number here on the left, right? So that means the quotient is going to be bigger. Okay, so think about that. So I have 1 over 4 cubic root of n minus 1 to be less than or equal to, sorry, greater than or equal to, right? 1 over 4 cubic root of n. Since this inequality is true, when I add the limits of the sum, that's still true. Okay. So now the question is like, what do I know about this series? Okay. Well, if I write the n term in this form, and if I pull out 1/4, let me just do it here. So this is like 1/4 n from 2 to infinity, 1 over n to the power of 1 over 3. Here we go. Well, this is a known series. In fact, it's a p series for p equals 1/3, which is less than 1 but greater than 0, right? And I know that p series diverge when p is less than 1. So here I know that this series is divergent. In fact, it diverges to infinity. Okay, divergence. Okay, so that's good because the series that I'm given in the question is bigger than or equal to infinity. What is bigger than or equal to infinity? Well, that's infinity. So that means this series is divergent as well. So here I'm using the second property here, as you see. If you have this series, let's say, divergent, then the one on the right is divergent as well. And we just proved that both series are divergent, but the purple one stays below the red one, right? And I know more about the purple one because it's a p series, and the red one, which is the one given in the problem statement, that is the sum corresponding to that infinite series is bigger than that. So if this goes to infinity, obviously this has to go to infinity. Okay, because it's bigger than the purple. Red is bigger than purple. So if the purple converges to infinity, then the red has to converge to infinity. Okay, so it's always to get like visuals like that, and this is just for the presentation purpose, just for you guys to understand the concepts better here. Okay, let's move on to part C.